Okay, so I realized that I made a mistake when I was discussing this problem 7a from, I think, homework 6. So I just wanted to kind of make a quick little video that goes over or what seems to be the correct solution. I'm still not 100% sure, but I'm pretty confident this is roughly correct. So for this guy, we know that, so our volume expression is going to be V is equal to, I'm saying that the side length is L, so we'll have L cubed. And then if we take the derivative of both sides, we get dV dL is equal to 3L squared. And the percent error of the volume is equal to 5%, which is equal to 1 over 20. That's 5% and 1 over 20 are the same things. I'm just writing one as a fraction. And then we are asked for the percent error in the side length. Okay, so we have this expression right here. So what we can do is, well, first off, we have to figure out what exactly is here. Let's do that in green. So no, well, that is way too thick. Give me thick. Thank you. What is the percent error going to be for the volume symbolically? And so what I mean by symbolically is just expressing it in terms of either the derivative or the volume. So some form of the two equations that we're dealing with now, and then we can substitute the 1 over 20 in later. So the percent error is, the way that you can think about it is you have a fixed volume and you want to look at how your volume has changed with respect to the actual or the true volume. So hopefully this will, yeah, this is thinner. So our true volume is just given by V, right? That's just the volume. And so I guess you could call it the deviation or the error. Actually, no, because technically it's not the error. The deviation from our volume is going to be given, should be given, I can write, by dV. Right, and that should make some sense. So our total volume is just going to be V, right? We know that the volume is equal to the side length cubed, right? And we know that we have a cubic swimming pool. So the deviation is going to be dV, because you can think about if I really need to adjust these thicknesses, holy crap. If I'm looking at just one side length of the swimming pool, right? So this is just this volume right here, not that far. Got a little excited. It's going to be V, right? So this is if you're looking at one side length of the swimming pool sort of edge on. So the error is going to be, you can think about it as being a little nudge that is dV. And so hopefully from this you can see that the percent error is just going to be the sort of infinitesimal little additional nudge, which is going to be dV. Jeez, how are people doing up there? dV divided by V, your total volume. So another way you can think about this, if it helps, is you want the total, you want the nudge per unit volume. And you can also think about this. I know when I was helping some people, I said that it's just going to be that the percent error is just equal to dV. So this is wrong for the reasons why I just explained over here. But also, you can think about this just in terms of units. So percent error isn't going to have any units, right? It's just going to be, it's just a ratio, right? Like percentages don't have any units. So it wouldn't make sense for this percent error equation right now to, the units of this would be in meters or feet or whatever units of distance we're using. And that doesn't make sense. So it can't be dV. We have to, it has to be unitless. So we have to divide by this V. So those are a couple perspectives that hopefully help give some motivation for why we need to do that. Okay, I'm just going to get rid of this. Erase, maybe. Okay. So with that in mind, well, the first thing that we want to do, this will select, give me green pen. Thank you. Is we want to move this DL over to the other side. So I'm just going to scoot this over just a little bit. So then when we do that, we get dV is equal to 3L squared dL. And now what we can do to find the percent error is divide both sides by V so that we get this equation. So we get dV over dV, or dV over V, sorry. And will that erase itself? There we go. Why is my computer lagging so much? Okay, I'm just going to leave that as a partial circle. We'll just live with it. Okay, so we know that dV over V is going to be equal to the percent error. So, and we know that the percent error, why, okay. And the percent error is just 1 over 20. It's equal to 3L squared dL over D over, oh, whoops, not dV, it should just be a singular V. Okay, now we can also make the substitution that we know that, okay, I guess this will just stay white even though I want blue. That's fine. We also know that V is equal to L cubed, so we can just plug that in right here. So then we get that 1 over 20 is equal to 3L squared dL over L cubed. And then we get 120 is equal to 3dL over L. So similarly, if the percent error in our volume is this guy right here, dV over V, then our percent error in the side length is going to be dl over L. And so we can see that we already have a dl and an L here, so we're already looking good. So now what I'm going to do is just divide both sides by 3, and so then we get that dl over L is equal to 1 over 60. And that is our answer. So that's the maximum. So I guess technically dl over L should be less than or equal to 1 over 60. Okay, so I hope that makes sense. I'm sorry I made that mistake. Yeah, that should be it. Let me know if you have any more questions. Alrighty. See you later.